Welcome back to Aurora Tech Channel. Today, I'm going to show you one of the easiest ways to transition from 3D printing to CNC machining. One of the reasons 3D printing has become so popular is how easy it is to get started. You can download a model online, open it in a slicer, click slice, send it to the printer, and in many cases, that's all you need to do. Modern 3D printers handle bed leveling, filament loading, calibration, and many other tasks automatically, making the entire process very beginner-friendly. CNC machining, on the other hand, has traditionally had a much steeper learning curve. The biggest challenge usually isn't the machine itself, but the CAM software. You can think of CAM as the CNC equivalent of a slicer. However, instead of automatically generating everything for you, you need to decide which cutting tool to use, which areas to machine, how deep each cut should be, the cutting strategy, feed rates, spindle speeds, and much more. That level of control is what makes CNC machining so powerful, but it's also what makes it intimidating for many beginners. The cost of CAM software is another factor to consider. While personal or student licenses are often free with limited features, commercial licenses can be very expensive. In fact, just 2 years of subscription fees can cost more than many desktop CNC machines on the market. Fortunately, that's starting to change. Makera is one of the few companies that has built its own complete software ecosystem. In addition to the machine itself, it provides both the machine controller software and CAM software free of charge. They've also launched Makerables.com, which is similar to a 3D model repository, but in addition to the 3D model, it also provides the CAM project file for you to modify, along with a ready-to-use G-code file. This means you can download a project and start machining it almost immediately without having to learn CAM from scratch. With this ecosystem, I believe Makera has made the transition from 3D printing to CNC machining much easier than it used to be. In this video, I'll go through a few different projects from their site, show you how the entire workflow comes together, and hopefully give you a good idea of how easy or how challenging it is to get started with CNC machining. First, let's take a quick look at the machine we'll be using today. This is the Makera Z1 Pro. It's basically the same as the Z1, their entry-level machine that starts at $1,100. The Pro version cost $400 more, and it came with 2 major upgrades. The Pro version comes with closed-loop stepper motors and ball screws, while the standard version uses conventional stepper motors and lead screws. Both machines come with a 150-watt spindle. It doesn't sound particularly powerful, but thanks to the rigid one-piece cast frame, it can machine aluminum at surprisingly aggressive speeds compared to most desktop CNC machines of this size. It also features a quick tool change system, allowing you to swap tools in seconds without using wrenches or manually tightening the collet. The working area is 200 by 200 millimeters with 100 millimeters of Z-travel. The machine is fully enclosed. It comes with a built-in dust collection system that allows chips to fall into the bottom tray, and you can connect it directly to your shop vacuum or use Makera's optional cyclone dust collector. Other features include an automatic probe that measures the surface of your material before machining, similar to the auto bed leveling found on 3D printers. It also includes a built-in camera for job monitoring and time-lapse recording. In the box, you'll find a basic set of cutting tools, mounting hardware, and various bits, all of which I'll be using throughout this video. There are quite a few optional accessories available. In addition to the cyclone dust collector, Makera offers a 4th-axis rotary module for machining more complex parts, a diode laser module, a 3D probe that can automatically detect both the material height and the X and Y positions, a vacuum bed, and a low-profile mini vise. As I already made a dedicated review of the Z1, this video will focus on using the real projects available on Makerables.com. I'll show you how to import them into the new Makera Studio software, which combines the CAM software and machine controller into a single package, and then take the projects from design to finished parts. I would like to thank Makera for sending us this machine to review and for sponsoring today's video. As always, even though this is a sponsored video, we won't hold back from pointing out any drawbacks or weaknesses we find during our testing. With that said, let's get started. Assuming you have no experience with CNC machining, the easiest way to get started is by visiting Makerables.com, Makera's CNC project website. Since it's still relatively new, there aren't a huge number of projects available yet. I roughly counted them, and there are currently a little over 250 projects available. let's find a project suitable for the Z1. In fact, even if the project wasn't originally designed for the Z1, once you've learned how to modify the CAM file, the workflow is basically the same. I'll start with a simple wood project. Let's make this poker card, scroll down a little, and you can see the materials and tools required for this project. It's a hardwood project that only requires a small piece of wood measuring 62 by 40 millimeters with a thickness of 12 millimeters. Of course, nobody has a piece of wood that's exactly the same size, but that's not a problem as long as your stock is larger. However, if the thickness is different, you'll need to adjust it in the CAM software. The tools required are a 1/8 inch flattened mill with a 17 millimeter flute length. I don't have the exact same tool, but I do have one with a 25 millimeter flute length, which should work just fine. The 0.3 millimeter engraving bit comes with the machine, so we're all set there. Let's download the files. There are 3 types of files available. The first is the .nc file, which is essentially the G-code used by the CNC machine. In our case, we want the CAM project file because we only need to modify the stock thickness while leaving almost everything else unchanged. I'll show you just how simple that is in the next step. You can also download the original design files, such as the STL or SVG. Since this is a 3D model, the design file is an STL. For this example, we only need the CAM file, so I'll download it and open it in Makera Studio. When you open Makera Studio, it will ask what type of project you'd like to create. Since we already have the CAM project, we can simply close this window and open the file we just downloaded. You can see that the project contains thousands of lines representing the toolpaths for 3 operations: 3D roughing, 3D finishing, and the contour cut that cuts the card out. Let's inspect them one at a time. I'll hide the finishing and contour operations and only show the 3D roughing operation. As you can see, this operation removes most of the material to create the rough shape of the king card. The project uses a 1/8 inch flattened mill with a 17 millimeter flute length. Since I don't have that exact tool, I'll use one with a 25 millimeter flute length instead. I don't even need to tell the software because the only difference is that my tool is slightly longer while all the cutting dimensions remain the same. Next, I'll hide the roughing operation and show the 3D finishing operation. You can see the toolpaths are much finer because this step engraves all of the detailed features of the 3D model. The tool used here is the included 0.3 millimeter 30-degree engraving bit. Finally, we have the contour operation that cuts the card out. It also uses the 1/8 inch flattened mill, so again I'll use my 25 millimeter flute length version instead. So far we haven't changed anything and are simply using the example project exactly as it was downloaded. However, there is one setting we must modify: the stock size. As long as our stock is larger than the project dimensions, we can leave the length and width unchanged. However, the sample project assumes a 12 millimeter thick piece of wood, while mine is about 13 millimeters thick. That means we need the cutter to go deeper. I'll simply change the stock thickness to 14 millimeters to ensure it cuts completely through the material. Next, go to the 2D contour operation and change the end depth from 11.5 millimeters to 14 millimeters. After applying the change, you can see that the software automatically adds a few extra cutting passes to reach the new depth. I'll recalculate the toolpaths to update everything. It looks good, so I'll click Export. Since my machine is connected through Wi-Fi, I can select all 3 operations and send the job directly to the machine. Before we start, let's take a look at the machine setup. The machine comes with a corner bracket that mounts at the bottom left corner of the spoil board. By default, every job starts from that corner. My stock measures 120 by 95 millimeters, which is much larger than the 62 by 40 millimeter project, so size isn't an issue. The material is slightly thicker than the original project, which we've already adjusted in the CAM software by increasing the cutting depth to 14 millimeters. I also have the optional mini vise, and I prefer using it whenever the material fits. The main reason is that I don't have to place another sacrificial MDF board underneath to protect the spoil board. In this case, I'll remove the spoil board entirely and mount the vise directly onto the aluminum bed. Then I can simply clamp my stock in the vise. It's not fully tightened yet, but I'll do that before starting the job. Since I'm no longer using the corner bracket, I need to adjust the job's starting position in the controller software. Click the margin button. By default, the software assumes you're using the corner bracket. Normally, you'd add a small X and Y offset to prevent the cutter from hitting the bracket. For example, setting both X and Y offsets to 5 mm moves the starting point safely away from the bracket. Since I'm using the vise instead, I'll roughly set the X offset to 30 mm and the Y offset to -10 mm. Let's run a preview frame to see if it matches my expectation. When I click Do Margin, a pop-up reminds me to install the probe. Since this is the first time I'm using the machine, it currently has the dummy tool installed, so I'll replace it with the probe. Then press the machine's only button to continue. First, the machine probes the tool height gauge, then it draws the preview frame. It looks like the frame is still a little too far from the left side, so I'll reduce the X offset to 15 mm while leaving the Y offset at -10 mm. Let's draw another preview frame. Okay, that looks much better. The controller's software also provides a full toolpath simulation. It starts with the roughing operation, and I can increase the playback speed for the preview. Once roughing is complete, you can see the machine automatically changes to the engraving bit for the finishing operation. Finally, it switches back to the flat-end mill for the contour cut. Everything looks good, so we're ready to start machining. Since we've already checked the margin, we can skip that step. You can choose Auto Z Probe if you only need to probe a single point on the stock to determine the Z height, or Auto Leveling if you'd like the machine to probe the work surface, similar to how a 3D printer performs bed leveling. For the vacuum and blow options, I'll test them later. For now, I'll just start the job. The machine begins by performing Auto Leveling. After that, it asked me to replace the probe with the first tool, the 1/8 inch flat-end mill with a 25 mm flute length. It measures the tool height again and then begins machining. The original project uses a 17 mm flute length tool. Even though mine is slightly longer, it's perfectly fine for this wood project. However, when machining aluminum, you should always use the same tool length specified in the project, or an even shorter one if possible, to maximize rigidity. The roughing operation is now complete. You can see it has removed most of the material, leaving the basic shape of the 3D design. Next, I'll replace the flat-end mill with the engraving bit for the finishing operation. The machine measures the new tool height and begins engraving all the fine details. Once that's finished, we'll switch back to the flat-end mill for the final contour cut. As you can see, it cuts completely through the material and the card simply drops free. Let's take a look at the finished card. It turned out beautifully. All of the fine details are crisp and well defined. Considering that the finished piece is only about the size of 2 quarters placed side by side, the whole job took about 30 minutes, from setting up the stock to the finished part. Not bad for our very first CNC project. Okay, let's try another aluminum project. This time I'm going to make this CNC clamp. Let's scroll down and look at the project details. It uses a 100 by 100 by 5 mm aluminum plate. Of course, I don't have the exact same size. The plate I have is 90 by 50 mm and 4.7 mm thick, so it's much smaller and slightly thinner than the example. However, this clamp is quite small, so I expect it to fit comfortably on my 90 by 50 mm plate. For the cutting tool, the project uses a 1/8 inch flat-end mill with a 12 mm flute length. This tool came with the machine, so we can use the exact tool specified in the project. There are 3 operations, and they all use the same tool, so we won't need to change tools during the entire job. Okay, let's download the file. Just like the previous project, it includes the G-code, CAM project, and original model files. In this case, since we don't need to change anything at all, we only need the .nc G-code file. Download it and return to Makera Studio. This time we don't need to use the CAM software. Instead, we can go directly to the Device tab, which contains the machine controller. Go to File Storage and click Upload to upload the file we just downloaded. The file will be stored directly on the machine, so even if the network connection is interrupted during the job, the machine can still complete it offline. The file is now here, so we can select it. It will load and display the toolpath preview. We aren't going to modify the file this time. We only need to tell the machine where we want the job to start. Go to Margin. Since I'm still using the vise, I'll adjust the X and Y offsets accordingly. I think an X offset of 15 millimeters and a Y offset of -10 millimeters should work well. Okay, the position looks pretty good. The job starts near the bottom of the plate, and it looks like I may even have enough material to make 2 clamps. I'll also let the machine run auto leveling. As you can see, the right side of the vise wasn't tightened completely, so that side of the plate is slightly higher than the left. However, since we're using auto leveling, this is a good test to see how much you can throw off the auto leveling. Now we'll install the 1/8 inch flat-end mill with a 12 millimeter flute length and start the job. When machining aluminum, the sound level stays in the high 50 decibel range and occasionally jumps into the low 60s. It isn't very loud and is not far from the noise level of an open frame 3D printer. The first operation is now complete. Since no tool change is required, the machine automatically moves on to the next operation. Finally, it runs the contour operation to cut the clamp out of the plate. Because my plate is thinner than the one used in the example, the tabs designed to hold the clamp to the stock weren't fully formed. As a result, the clamp simply dropped free when the contour finished. I actually prefer this because I don't need to cut the tabs manually, remove them, or smooth the edges afterward. I also enabled the vacuum, auto blow, and bed clean options for this job, so let's see how well they perform. The system did remove most of the debris from the bed and the finished part. However, it seems the blower isn't powerful enough to push all of the aluminum chips toward the bottom of the machine, where the dust collector can suck them up. The finished clamp looks very nice. This is definitely a usable CNC part. The total job time was about 32 minutes, and the clamp we made looks very similar to the one included with the machine. I then tried to make a second clamp, but I made a fairly obvious mistake. Once the second clamp was almost finished, there was no longer enough material left for the vise to hold securely because most of the plate had already been removed. As a result, the remaining stock flew out of the vise. I don't blame the example project or the machine. If my aluminum plate had been larger, or if I had mounted it directly onto the spoil board, it probably would have been fine. Okay, let's try one more project. This time, I'll be making this World Cup trophy. As you can see, it's a much more complex 3D model that requires the 4th axis module. Since I'm going to stick with the original project as much as possible, without making any modifications, it shouldn't be much harder than the previous projects. Let's first take a look at the stock. The original project uses a piece of hardwood measuring 100 by 35 by 35 millimeters. I don't have that size of wood on hand, but I do have this oak dowel from Home Depot that's normally used for closets. Its diameter is slightly smaller at about 32.5 millimeters instead of 35 millimeters. But since the model itself is smaller than the stock, I think it should still work. For the tools, the roughing operation calls for a 42mm flat-end mill. I only have a 25mm one, but since the stock is only 35mm in diameter, even when machining all the way to the bottom on the 4th axis, the cutting depth shouldn't exceed 17.5mm, so the shorter end mill should work fine. For the finishing pass, the project uses a 1x4mm ball nose end mill. I only have a 1x3mm, which I also think should work without any issues. Even though both my stock and cutters are slightly different from the original project, the differences are minor, so I'll simply download the provided G-code file. We don't even need to open the CAM software. I'll go directly to the CNC device, rename the file using only English characters, and upload it to the machine. This file is much larger than the previous projects, so it takes about 2 or 3 minutes to upload. Okay, it's done. I'll select the file and switch back to the device control page. Everything looks normal, and the only thing I need to set is the X offset. The most important thing is making sure the cutter doesn't hit the 4-axis chuck. I first tried 45mm, but that was a little too close, so I ended up using 50mm. There's no need to set a Y offset because in a 4-axis job, the cutter moves in a straight line while the stock rotates. Let's do the margin and check the preview. Everything looks safe, so we can start the roughing operation. Since my stock is smaller than the original project, the end mill will spend the first 2 to 3mm cutting air before it actually touches the wood. I can already see that one side of the cylinder is missing some details because my stock is slightly smaller than the original. I also don't think I mounted it perfectly straight. If the stock were larger, we'd have some extra margin for error, but with slightly undersized stock, that margin is gone. Let's continue and see how it turns out. Now I'll switch to the 1x3mm ball nose end mill for the finishing pass. You can see one side of the globe looks perfect, but on the other side, the cutter isn't touching the surface at all, so we can expect some missing details there. Okay, the entire job took about 2 hours to complete. Even though I used a smaller stock and shorter end mills, the results actually aren't too bad. One side looks exactly as expected. However, because my stock wasn't mounted perfectly straight on the 4-axis, the other side is missing some details. If this were a real project instead of just a test, we'd probably want to modify a few settings in the CAM software. Once the CAM file is open, the first thing we should do is change the stock from a square block to a round bar, since we're machining a cylindrical piece of wood. Then set the stock diameter to 32.5mm. Next, we should scale down the model. Right now it's close to 32mm in diameter, leaving only about 0.5mm of clearance compared to our 32.5mm stock. That's simply not enough margin for error. Since it's difficult to mount the wood cylinder perfectly flat on the 4th axis, even a slight misalignment can cause one side of the model to lose detail, which is exactly what happened here. To give ourselves a better safety margin, I'd shrink the model down to around 28mm, move it to the left so it sits on the base, and then recalculate all the tool paths. Now we have a slightly smaller model that fits the stock much better. Even if the round stock isn't mounted perfectly straight, we have enough extra material to compensate for the misalignment and avoid losing details. After watching me do a few different projects I chose from Makerables.com, including using ready-to-use G-code with almost the exact same stock size, as well as making a few adjustments to adapt the project to the stock you have, I hope you now have a good idea of how easy or challenging CNC machining can be. A major difference between Makera and other CNC machines is that you're not just buying the hardware and then having to find separate CAM and controller software, whether paid or free with limited features, just to get the machine working. All Makera machines come with an entire ecosystem that includes the CAM software, machine controller, and this new CNC project website, all available to users at no additional cost. For now, the biggest limitation of the site is the number of available projects. I roughly counted them, and right before this video was released, there were only around 250 projects available. Since the site is still new, and most of the projects were uploaded by Makera themselves, I expect that number to continue growing over time. In fact, I've already started seeing what appear to be projects uploaded by other users. But even so, I still found this website to be very useful because you can download not only the ready-to-use G-code, but also the CAM project file and the original 3D model. This allows you to study how the CAM project was created, examine all of the machining parameters and settings, and learn techniques that you can apply to your own projects. As for the machine itself, if you'd like to see my in-depth review of the Z, one that focuses more on the hardware, I've already made a dedicated review video. If you want to learn more about the CAM software, I also have a dedicated beginner's guide that walks you through every step from start to finish while completing several projects with different levels of difficulty. Makera also has its own wiki website that explains the software in detail, which I think is an excellent official learning resource. You'll find links to all of them in the description below. The Z1 was already on my recommendation list at auroratechchannel.com, where I ranked it as the best performance mini desktop CNC. Since the Z1 Pro is essentially an upgraded version of the same machine, I won't be adding it as a separate recommendation. My website also features price trackers for popular 3D printers, CNC machines, and laser engravers, making it easy to compare current prices and find the best deals. That's it for this video. If you found this video helpful, please give it a like and consider subscribing to our channel. Thank you for watching, and I will see you next time.